Hi girls, I hope you're doing good at home. To continue with metallurgy in chemistry, today we are going to talk about how metals are extracted. You know that the metals which are high above in the activity series do not occur free in nature because they are very reactive, so they are found as compounds. So various metals that we use in our daily life like aluminum, iron, copper, tin must be extracted, that is separated from its compound state. Okay, then only we can get it and use it in a daily life. So there are various physical as well as chemical methods used to extract the metals from the ores. Okay, the compound in which the metal is found is known as the ore. So the extraction of a particular metal depends on the nature of its ore and the properties of that certain metal. So all metals cannot be extracted using the same method. So extraction of the metals from its ore consists of the following steps, which we will be discussing in detail. First is crushing and grinding of the ore. Next is concentration or dressing, which is also known as benefaction of the ore. Next is conversion of concentrated ore by oxide by process which is known as roasting or calcination, reduction of metallic oxide which is known as smelting, and refining or purification of metal so that we get the pure metal at the end. So to define metallurgy, it is a process used for extraction of metals in their pure form from their ores, and this process is known as metallurgy. So when we talk about metallurgy, we are talking about the production and purification of metals, and of course the manufacture of alloys as well. You know, alloys are a mixture of 2 or 3 metals to make it more durable, more stronger or lighter accordingly. The first step in the extraction of metals is crushing and grinding. So the ores are crushed into a very fine powder in big jaw crushers and ball mills. So the ore is placed in the big jaws of crushers and ball mills, and then it is grinded into a very fine powder. The process is known as pulverization. Okay, next is the dressing and concentration of ores. So you know this process removes the gangue. If you remember, gangue is the earthly impurities, the rocky impurities like silicon dioxide which is present in the ore. Okay, so this process is known as concentration of an ore or ore dressing, and the pure ore that we get which does not have gangue, the earthly impurities, is known as concentrated ore. Okay, so the concentration of the crushed ore is done by the following methods. First is hydraulic washing or gravity separation, or it is also known as levitation. And what is the principle behind it? The difference in the densities of the ore and the gangue. That is, the ore is heavier and the gangue is lighter. So here you can see how it is done. The ore is poured on a corrugated table which has grooves. It is slanting and it is constantly vibrating. Okay, and when a jet of water is sprayed over the powdered ore, what happens? It will start flowing along with the water. The lighter gangue particles will move right down and it is separated. The heavier or the denser ore particles will settle down in the grooves. So hence the ore and the gangue are separated. Okay, next is magnetic separation. So you know the principle is magnetic properties of the ore. Okay, so what happens? The crushed ore is placed over a conveyor belt. You know, a conveyor belt continuously rotates, it moves. Okay, and there are 2 metal wheels, one of which is magnetic. Okay, so here you can see this is the ore which is poured down through here. Okay, so there the powdered ore will start moving along the conveyor belt. This one is the magnetic wheel. So if the ore is magnetic or if the gangue is magnetic, it will remain attracted to the wheel and it will move till here. But the one which is non-magnetic, either the ore or the gangue, it will move and form a separate heap. Okay, so we have non-magnetic ore, or it may be magnetic ore, and there we have magnetic gangue, or it may be non-magnetic gangue opposite. Okay, it will form opposite heaps. If the ore is magnetic, you will get the ore this side, or if the gangue is magnetic, you will get it this side. Okay, so this is how it is separated. So this method is used to concentrate tin stone, that is tin dioxide, which contains magnetic oxide of iron, okay, as impurity. So actually this gangue that we have separated when we are concentrating tin stone is actually magnetic oxide, so it is forming a separate heap here as magnetic gangue. Okay, next is froth flotation. Okay, the principle is it depends on the preferentially wettability of the ore with oil. That is, the ore will get wetted with oil, especially pine oil, and the gangue particles by water. So ore is getting wetted by oil and the gangue is getting wetted by water. Okay, so the crushed ore is taken in large tank containing pine oil and water. Okay, and then potassium ethyl xanthate is added to it. Okay, and then a current of compressed air is passed into the tank. So what happens, it becomes like it gets agitated, it starts moving about, the water and the oil, it will start moving about, okay, very quickly, vigorously. Now what happens when it is moving vigorously, the ore gets wetted by oil and gets separated from the gangue in the form of froth. You know, froth bubbles which comes out to the top, because you know oil floats on water. Okay, so the ore comes up with the oil, so the impurities get wetted by water and remain behind in the tank. Now since the ore is lighter, it comes to the surface with the froth and impurities are left behind. So you have sulfides like zinc blende, zinc sulfide, and galena, lead sulfide. Remember children, these names of ores are very, very important. So zinc blende and galena are lighter than the impurities present, so they are concentrated by froth flotation process. So here you can see the powdered ore, water and pine oil. Okay, and compressed air is passed in through here. So when it passes through, this whole thing gets agitated. Okay, so here there is water, here there is pine oil, here pine oil and water, so it gets agitated, and when the compressed air is stopped, what happens, the oil will come to the surface and the oil will wet the ore and it is lighter, so it comes up to the surface here. This is the froth. Okay, and then the froth is separated from here, and finally in the tank what is left, the gangue or the matrix will be left behind inside the tank, and the froth with the sulfide ore is separated. The next method is the chemical method, or which is also known as leaching. So here the ore is treated with a suitable reagent. It may be an acid, base, or some other reagent, so that the ore is soluble in it but the impurities are not. Okay, so the impurities are removed by filtration. Okay, the solution of the ore, that is the filtrate, again is treated with another reagent which will precipitate the ore. Okay, so we'll be doing that when we learning about the extraction of aluminium. Now the leaching method is used for concentration of metals like silver, gold and aluminium. However, the ores, even after their concentration, still contain some impurities, gangue. To remove the gangue, certain substances called fluxes are mixed with the concentrated ore. So the added flux combines with the gangue to form a fusible mass which is known as slag. Fusible means it is melted. Okay, so slag is usually lighter and floats on the surface of the molten metal, and so it is removed easily. So what happens, even after the concentration there are some more impurities left. So to remove that impurity, another substance which is known as flux is added to it. The flux combines with the gangue and it forms another separate mass. So that mass is known as slag, which is light and floats on top of the molten or the melted metal, and it is separated. Now, conversion of concentrated ore into its oxides. So concentrated ore is turned into or converted into its oxide, because oxides are easier to reduce into metals. Remember, all the metals, to extract all metals, it must be in the oxide form, because it is easier to convert oxides into metals. It can easily be reduced. Okay, so depending upon the nature of the ores, two methods are used to convert the ore into oxides. First is known as roasting, and the other is known as calcination. So what is roasting? Roasting is nothing but it is a process of heating the concentrated ore to a very high temperature in the presence of air. Okay, during roasting, what happens? Moisture is removed because it is heated. Next, organic matter, if any, in the presence of air, oxygen gets oxidized, and that is also removed. And impurities of sulfur, phosphorus, and arsenic also are oxidized and removed as volatile impurities. Volatile means which changes into a gas. So sulfur and oxygen give sulfur dioxide. We are getting this oxygen from the air we are roasting it with. Okay, phosphorus will form phosphorus oxide. Okay, arsenic will form arsenic oxide, and then they are removed. Now metal sulfides are oxidized to metal oxides. Okay, metal sulfides, sulfide must turn into oxides. Okay, so zinc sulfide, lead sulfide, and iron sulfide, okay, they are roasted in the presence of air. Actually, we need oxygen. What is formed? Zinc oxide, lead oxide, ferrous oxide, okay, and sulfur dioxide will go off as gas. Okay, so hence now we have oxides from where the respective metals will be extracted. Zinc, lead, or iron will be extracted. Now roasting makes the ore porous, and so ore gets heated uniformly, so it becomes porous. That is, heat will go into the ore in equal amounts. Okay, next is calcination. Now what is calcination? If the ore is a carbonate or a hydrated oxide. Hydrated oxide means oxide which has water of crystallization with it. It is heated, remember, in the absence of air. So what is the difference between roasting and calcination? Roasting is in the presence of air, calcination is in the absence of air, to a temperature that is high temperature, but insufficient to melt the ore. The ore should not be melted. Okay, so this process is known as calcination. So on calcination, metal carbonates and metal hydroxides get decomposed to give the metal oxide. So what is our aim here? We are actually turning the compounds into oxides. Okay, so we have zinc carbonate, calcium carbonate, which turns into zinc oxide and calcium oxide. We are heating this in the absence of air. Okay, and then carbon dioxide will go off as the gas. So moisture, water of hydration, and other volatile impurities, volatile means which can evaporate easily, present in the ore gets removed. So ore becomes porous, and again heating of ore is uniform. So here you have a table comparison of roasting and calcination. So this is the first assignment for today, which you will submit day after tomorrow. Please write down the difference between roasting and calcination. That is your first assignment for today. Okay, and learn it. Now, reduction of metal oxides. Now we got the ore as an oxide. Okay, so now we need to reduce the metal oxides to metal. That means we need to remove the oxygen and then get the metal. So that is after roasting or calcination. The metal oxide is reduced by heating it with reducing agents like carbon monoxide, or hydrogen, to obtain the crude metal. Okay, it is not pure. Crude metal means it is not pure metal. So the selection of reducing agents, you have to select the reducing agents in such a way that you have to see the position of the metal in the reactivity series. Now, oxides of highly active metals like potassium, sodium, calcium, magnesium, and aluminium, they have a great affinity towards oxygen. So it is not easy to reduce them by using common reducing agents like carbon, which is coke, carbon monoxide or hydrogen. And if you remember, we did the separation of these in the electrolysis chapter. So these metals are obtained by electrolytic reduction of fused metallic salts, halides or oxides, using inert electrodes. So cathode, remember we did that in the electrolysis chapter. So cathode is made up of the iron and anode of graphite. I've already explained this in the electrolysis chapter, but a quick recap. If you remember, the electrolyte used is fused potassium bromide when we are extracting potassium. Okay, so reaction at the cathode, potassium will gain the electron that it had lost and turn into potassium metal, and at the anode, bromine will lose the electron that it had gained, and it will turn into one atom of bromine. Two bromine atoms will come together to form bromine vapors, reddish brown vapors at the anode. Similarly, for extraction of sodium, okay, electrolyte used is fused sodium chloride, melted sodium chloride, so which will break down into sodium and chlorine ions. Sodium will move towards the cathode and it will gain the electron that it had lost to turn into sodium metal, and at the anode, chlorine will lose the electron that it had gained to turn into chlorine atom. Two chlorine atoms will come together to form the chlorine gas, which is a greenish yellow gas that will be seen evolved at the anode. Similarly, for calcium, the electrolyte used is fused calcium chloride. Okay, so it will break down into calcium and chlorine ions. Okay, so at the cathode, the calcium will gain the two electrons that it had lost to form the calcium metal, and at the anode, again, what happens? The chlorine will lose the electrons that it had gained to form one atom of chlorine. So two atoms of chlorine will come together to form chlorine gas. A greenish yellow gas is evolved at the anode. Okay, so reactive metals, remember, cannot be extracted from their aqueous salt solution by electrolysis because they react with water. Now, aluminium is also obtained from its oxide by electrolysis. The metals in the middle of the activity series like zinc, iron, lead, copper are moderately active, so they are usually present as sulfides or carbonates in nature. So first they must be turned into oxides. Okay, they are converted into oxides by heating in excess of air, that is by roasting. Okay, because oxides, as I told you, are easy to reduce by using reducing agents. Okay, so zinc sulfide, known as zinc blende, the ore, okay, it is heated very high temperature, 800 degrees Celsius, in air where oxygen is present, and it turns into zinc oxide and sulfur dioxide. So the carbonate ores, they are heated in a limited supply of air or in the absence of air. The process is known as calcination, and they are turned into oxide. So zinc carbonate, which is also known as calamine, it is heated in very less air or in the absence of air to turn it into zinc oxide and carbon dioxide, which will go off as a gas. So the metal oxides are then reduced by using suitable reducing agents like carbon reduction process. Okay, that is, carbon is used. Zinc oxide and coke, that is carbon, they are heated in a retort by producer gas. So what is producer gas? Carbon monoxide and nitrogen to get zinc spelter. Okay, so here you can see zinc spelter is actually impure zinc. Okay, so zinc oxide and carbon at 1400 degrees Celsius will give us zinc spelter and carbon monoxide, which is a gas. So zinc oxide cannot be reduced by carbon monoxide or hydrogen, as they are unable to overcome the affinity of zinc towards oxygen. Okay, that is, zinc has a great affinity towards oxygen. So zinc oxide is reduced only by heating with carbon, which is a stronger reducing agent as compared to carbon monoxide and hydrogen. Iron, lead and copper are obtained by the reduction of their oxides with carbon, carbon monoxide and hydrogen. Okay, so your Second assignment for this week, which you'll submit day after tomorrow, is to write down how iron oxide, lead oxide, okay, and copper oxide are reduced with carbon monoxide and hydrogen. That means you'll write all these equations. So iron oxide with carbon, when it is heated, you'll get iron, and carbon monoxide with carbon monoxide, you'll get iron and carbon dioxide. With hydrogen, you'll get iron and water vapor. Similarly, lead oxide with carbon, you'll get lead and carbon monoxide. With carbon dioxide, you'll get with carbon monoxide, you'll get lead and carbon dioxide. And with hydrogen, you'll get lead and water vapor. Remember that lead is a grayish white metal, okay, and lead oxide is yellow. So all these colors are important. Now copper oxide, which is black in color, with carbon will give you copper and carbon monoxide. With carbon monoxide will give you copper and carbon dioxide. With hydrogen you'll get copper and water vapor, and the color of copper is pink or pinkish red or reddish pink, okay. This is the color, please remember that. Now the highly reactive metals can be used as reducing agents because they can displace metals of lower activity series from their compounds. For example, in order to obtain manganese, its oxide is heated with aluminium powder, okay. Aluminium is higher in the activity series. To get manganese, aluminium oxide and heat. Manganese you'll get as a liquid, aluminum oxide is a solid, okay. Now aluminium is a very powerful reducing agent. When a mixture of aluminium powder and iron oxide is ignited, that is when it is burnt, the latter, that is iron, is reduced to a metal. This process is known as aluminothermy, okay. What is aluminothermy? When a mixture of aluminium powder and iron oxide is ignited, okay, it is burnt, you'll see that iron oxide will turn into metal, okay, and aluminium oxide, and heat is given out. So these displacement reactions are exothermic. Exothermic means heat is given out. So the amount of heat that comes out in this reaction, okay, produces the metals that you get will melt, okay. So this iron that you get here, you'll get in the melted form. So metals which are low in the activity series are very less reactive. So the oxides of these metals can be reduced to metals by heating alone. You just have to heat them, and then it will, the oxygen will go off and the metal will be separated. So if we are to get mercury from mercury sulfide, which is also known as cinnabar, the ore, okay, it gets converted into its oxide simply by heating in air, okay. So mercuric sulfide, cinnabar, when you heat in the presence of air, it will turn into mercuric oxide and sulfur dioxide, and this mercuric oxide on further heating is reduced to mercury. That is, the temperature must be above 300 degree Celsius. So you will get the metal mercury. Similarly, silver also, if you heat it in a similar manner, you will get silver, because they are lowermost in the activity series, okay. And copper, which is found in nature as copper sulfide, is obtained from its ore by just heating in air. First, when you heat in air, you'll get copper oxide, okay, and the copper oxide, okay, when you heat it further, it will reduce into copper, the metal, and sulfur dioxide, which is a gas, will go off. So this method is known as auto reduction process, okay. And similarly, silver also can be obtained by the displacement method from solutions containing its ion by more electropositive metal like zinc, okay. So in solution, when there is a reaction, the zinc will turn into zinc ions and the silver metal will be free, okay. So we will stop here today, children. In the next upload, we will start from refining of metals, okay. So I've already given you the assignment. So till then, children, stay safe. God bless you.